Hi, let's do adding, subtracting, rational fractions, part 2. And we got 3 examples today. I know I said we'd probably do 5, but I only, for the space on the board, I'm gonna do 3. And then over there, we're gonna look at the rational function from yesterday's Desmos and talk about the hole that you were supposed to find and what you're supposed to cross out, okay? All right, let's jump into it right here. Remember yesterday's lesson, we're looking for a common denominator. Definitely don't have that there. So you have to multiply each fraction times what it's missing to get the common denominator. And one of the easiest ways to get a common denominator is just to multiply denominators together. Okay, so that was all yesterday's discussion. So if we multiply these together, simply put, it looks like this. You've got 2x times 20x plus 16. I would hold off on multiplying that together until you look for cancellation. Okay, so let's just wait on that. And then over here, we've got the same denominator because we're multiplying them together. Go a little longer on that. Okay. Now, what is missing from this denominator to this one? Well, it's the 20x plus 16. So we're going to multiply that to the top. So all I do is write it down on the top. That's the missing piece. And then I put the numerator that was there next to it. Okay? Let's do that again over here. What's missing from this denominator to this one? It's the 2x. So I just write that down on the top. And I also write the numerator in parentheses, of course, that was there before. All right, now it's just a little bit of distribution work and looking for cancellation. Okay, so let's go ahead and do that work. 7x times 20x is 140x squared. And then we've got 7x times 16, which is, anybody quick, 7 times 16. 7 times 10 is 70. 7 times 6 is 42. 70 and 42. 112? Okay, 112. Don't forget there's an x on that. The next distribution, what I would do is I'd make it a plus negative, okay? So the terms out of this are going to be negative. I could go ahead and switch the signs right here, or I could give that negative to either one of these, okay? So let's just keep in mind that when we distribute back this way, 2x times x is 2x squared, but it's negative, okay? And then 2x times negative 2 is negative 4x, but if you turn it to its opposite, it's now positive. Okay. All of that goes over the common denominator. 2x times 20x plus 16. Because once you add your numerators, you just put it over the common denominator. Let's simplify the top. See what we get out of that. So I see 140x minus 2 is 138x squared. And then 112 plus 4 is 116x. That's on the top. And on the bottom, we still got this guy down here. Okay. So we've gone this way. We've circled back over to here. And now we're looking at the top and the bottom, and we're looking for cancellation, okay? So do you see a GCF, yeehaw, a common factor out of 138 and 116 that we could pull out of there? I'm thinking a 2, just for starters. I know we could get 2 out of that, okay? Oh, look, I got my calculator here. My apologies. Okay, we're gonna take out a 2 and an x because I see that in both terms. Divide both terms by 2x. This one turns into 69x, and this one divided by 2 is 58. Okay. All over. Oh, that's interesting. Do you see why that's interesting? Look, the 2x is canceled. Yes, you're allowed to do that because you factored out the 2x, and it's a common factor between the top and the bottom. Essentially, it'd be like this. If you had 10 over 20, let's use this space right here if you don't mind, and you said that's 5 times 2 over 5 times 4, you could cancel the 5s. Now, that wasn't the best way to go because I didn't get the GCF, but yeah, you still have to simplify from there. you really did the same thing. You factored something out and you canceled it. Okay. So I'm gonna call this one good. Take a look over here. What number is this? 9. On the wrong page. Yeah, it's good. The only thing they did is they took a 4 out of the bottom. So we should probably do that too. Done. All right, let's look at number 15. Same idea. We're looking for a common denominator between the two. So I see, well, you know what we could do there? This might help. All right, so take a look at these. See the GCF is 3. So in its place, you could write it like this. Both out of 3. Divide both terms by 3. Oh, I just put a marker on my hand. That'd be 5x plus 1. So now you see this has a factor of 3, this has a factor of 3. The only thing that's missing is the 5x plus 1 from this one. So we don't have to change that one. I feel like if you had a 5 and a 10, and you keep the 10 and you just make the 5 into 10. Okay? Same deal. So let's go, let's do this the same way, statement. Here we go. We've got 3 times 5x plus 1 as our common denominator for both fractions. Okay? Now, what's missing from this one? The 3 needs the 5x plus 1. I'm going to write that on the top. And we've got the 6x sitting right there. Okay? Over here, you've got the same thing. The denominator doesn't change, so the numerator doesn't change either. You're just going to leave it as a 7. Okay? And now let's go ahead and do some distribution. So we've got 6x times 5x is 30x squared. 6x times 1 is 6x. Let's add the 7 plus 7 and put it over the common denominator of 3 times 5x plus 1. Now, if you take a quick peek at the answer key like I did, that's exactly what they have right there. You always want to check, though, for cancellation like we saw back here, which I erased it, but remember when the 2x's canceled? Okay, so I could fit my answer on there. You'd look to factor this quadratic, see if you could get it to cancel with this 5x plus 1. It's not going to happen, but it's always a worthy pursuit to try to do that. Okay? All right, let's go over to 21. Do we have a common denominator? No. We have an x minus 2 and an x plus 1. So let's multiply those together. X minus 2 times x plus 1. X minus 2 times x plus 1. Okay? What's missing from this denominator to this one is the x plus 1. So you write that on the top. And don't forget there was a numerator already there. Over here, same deal. What's missing from x plus 1 to turn it into this is the x minus 2. Need that. And there was a numerator sitting right there, also a 6. And now we're going to follow the same template that we did here and here. We're going to look to distribute 6 times x, 6 times 1. 6x, 6. 6 times x, 6 times negative 2. 6x minus 12. All over the common denominator of x minus 2 and x plus 1. Okay. Let's combine like terms. So you've got 6x and 6x makes 12x if you combine those two. So I'm going to go down to a knee again. I've had to do this a lot lately. And then we've got 6 minus 12 is minus 6. Okay? All over x minus 2 and x plus 1. Take a quick peek over here. That's what it says. Whew, boy. That's a lot of work. You know what? I need some time to recuperate before I get into this. So we're going to do a rational function over there, the one in the decimals from yesterday. Hey, can I have like some warm-up pitches before I get going with this? Yeah, okay. Yeah, if you need time, that's fine. Thanks. Okay, right here, buddy. All right, fastball. Okay, thanks. All right. All right, here comes curve. Oh, that was nasty. Oh, that was nasty. All right, I'm ready now. I ain't gonna tell you what's coming though. I ain't gonna tell you. You will not know what's coming. Mini-me? Oh, never thought Mini-me would betray me like that. Boy. Well, let's get back to business. Okay, so this was the rational function from the Desmos activity yesterday. And as you saw in the message to students, we had some issues, okay? Now let's go over what you should have got. And most people got these things, so we're not in that bad a shape. Remember, y-intercept, you're gonna plug in 0 into the function every place that you see an x. We got 0 minus 4, we got 0 squared plus 2 times 0 minus 24. Wipe out, wipe out, wipe out, negative 4 over negative 24 is positive 1 over 6, okay? Now that's a y-intercept, so I want you to write it as a coordinate. If you're not doing that in Desmos, do that today. Write it as a coordinate today, okay, for the y-intercept and the x-intercepts. Now the x-intercepts, there might be 2, okay, so remember, we take the top and we bring that down, we set it equal to 0. Looks like it's just gonna be 1 because that's a linear. So x minus 4 equals 0. Add 4 to both sides, x equals 4. Okay? So now we want to look at, if there's a hole later on, this thing might not exist at x equals 4. For the moment, let's write it down and put a pin in that for later. Okay? Come back to this. That's a star. Vertical asymptotes. This is where we take the bottom and we set it equal to 0. Okay? It's a quadratic. So when you solve that quadratic, you might get 2 solutions. X minus 24 equals 0. I'm going to factor. Hope you guys are brushing up on your factoring skills. 2 numbers that multiply to negative 24 and add to 2. So multiply to this number, add to that number. I'm thinking plus 6 minus 4. Okay, those are the 2. And then you set both those equal to 0. X plus 6 equals 0. So does x minus 4. And you get x equals negative 6 and x equals 4. Now you should see something right now that is a glaring, not error in our work, but just something that cannot be. How can it cross the x-axis at 4 and there be a vertical asymptote in the same place? That doesn't seem right. So now we go to horizontals. We'll put a pin in that too, okay? And after that, we'll look at our holes. Okay, so horizontals. This is if the degree of the top is less than the degree of the bottom, which is this case. It's always the x-axis. This week, we're going to start talking about slants. We didn't do it last week. We need to start this week. And that's going to be a mini lesson on polynomial division. We'll get into that. Okay, let's talk about holes. On the top, you have x minus 4. The bottom, we've already factored into these 2 binomials, x plus 6, x minus 4. Okay, so that tells me that the x minus 4's cancel. That's where the hole is right there. You have to set that part equal to 0 to find it. So x equals 4. Or when x is 4, there is a hole. Okay? Let's go back real quick to mini-me, to see if that's true.
You good?
It is true. Awesome. I like when things are true. Have a tubular Tuesday. Marker toss! There's no garbage can.